Hey guys, today we will learn about lecture 11. We previously learned about the power, for in the power system, but we will look through more deeply the equation. What does that mean? And we will try to drawing the page, you know. So let's see more. First of all, yes, here is I will say sending VS or just simply say I V1. And this is the receiving part, I will say. VS, VR, receiving part, or V2, right? More easily. So this is in the power system, power, flow. You guys may see this equation later, you know what I mean? So this is the sending part, I will say S1 and S2. Here's S2, right? So we already learned why we need to here the conjugation, right? Previous lecture. And then I will show you how to, find out this. So let's see. Actually, you don't need to know about this because just remember it's fine, the result, you know what I mean. But let's see, okay, what's happened. Okay. Yeah, let's see. First of all, we need to draw the power system, right? This is sending V1 or V1, and the V2 receiving, right? And here is JX, and current is coming from here to here, right? And theta 1 and V2 and theta 2. I will say between V1 theta and V2 theta's angle differences from here. So I will say delta. Okay. So first of all, we need to make it this drawing, power system. And then first step this. Second step, make it the equation, voltage equation. So V1 and theta 1 equal to V2 and theta 2 plus J I X is our equation, right? And third is we need to make it find out the current. How do we find out? Current is V1 theta 1 minus V2 and theta 2, and JX is our current, right? And I'll show you only sending part S1. Okay, S1 equal is VI, and a conjugation need to I here, right? And if we conjugate here, what happened? Here's imaginary number. We add a minus, and here angles, we need to add a minus. So I'll show you. So V1, theta 1, right? Multiply this part we need to make it, right? So V1, but I said the conjugation which means minus, right? Minus theta 1, minus V2, and minus theta 2, and then minus JX. So what happened? VV is V1 at 2, right? And then if we edit this is 0, so I will say 0. And then if we edit multiply this, right, to this also V1, V2, and then theta 1 minus theta 2. But I will say this is equal delta here, right? And then minus JX, right? So we want to remove minus J here. So we will multiply JJ. What happened here? So J, V1 to 2, and 0, and minus J, and then V1, V2, and delta. And then here's a X, right? So from here, we wanna to polar coordinate to the change complex number, because we wanna find out finally separate real part and the reactive part. Reactive, which means a real number and imaginary number, right? So we need to change it to the complex power complex number, right? So what we need to do is here, x, j, v1 to 2. And since this is 0, I will just don't write down, okay? And then we need to use minus j, v1, v2, cosine delta plus j, v1, v2, sine delta. This part about a little bit about the math. You will find out why it's I'm doing like this. But actually, I said you don't need to know about this process. Just remember the result is fine. So we want to separate, by the way, real and the imaginary number, right? So here you can see j, which means it make it the real number, right? So first of all, we will try out the p part first, which means v1, v2, sine delta x, yeah, plus j, and then v1 to 2 minus v2, v1, v2, and cosine delta. This is a q, right? And this is a p. So let's see. Yeah, that's how we find out this this is our equation. So let's move on. Okay, right bottom, I don't need it. So let's see. So you guys can see I found out the equations result, right? So let's see more. And this second part, receiving part is also same, but just you guys can see P is same, but Q is changed, right? Here, the equation. Where is it? Here, it'll be changed. Yeah, yeah. Just memorize. Later, you guys learning more about it. So let's see more. Okay, and then here, this part. So we will look through first P, real power. What happened here? So here, look at that, guys. So first of all, here. So P is related here. Why? Look at that. Y through. And this is a delta, right? Between this angle. So result is P is related this angle, the magnitude. We say this is here cosine, and this is sine. So you could see here, this is number 1, and this is number 2. The P is, magnitude is different, right? Between the angle, which means if we add more angle here, sine delta, which means the P is, from here to here. It's moving, right? From the largest, larger with the magnitude is, to the downside of, magnitude, the P's. It's related this angle. You know what I mean? Then more clear. Let's see. Then okay. And third part here, Q. I will say Q is we saw this equation, right? So what I wanna say is here, guys. So here, this is current is here coming through, right? But theta is here. So theta is here same, right? This is cosine. That's why I said P. And this is sine. Sine is Q. So what? So result is it's related reactive powers from power flow is I said it's related this magnitude, right? the real power is this angle, but reactive power is here's magnitude, right? Because theta. So look at that. For example, so here. So if we add more, reactive current here, like this, like this side. Here is a cosine, right? And this is a sine, right? So if we add a reactivers like this, what happened? Look at that. For example, this is yeah. I need to more clearly. I need to. So look at that. If it's here, so current is if it's here, so which means 90 degrees here, right? Add through this. This is actually voltage drop, IJX, right? But if we added this current is here, what happened? Sorry, guys. It gotta be here, right? Voltage drop is this line. So, but if we didn't change it, this receiving part voltage, you know what I mean? If we didn't control, what happened? If the VR side is more higher than VS, what happened? Penalty effect happened, right? So let's see here. Where is it? So look at that. What I want to say is here. So you guys can see the gray one, first of all, gray one was here, right? But because of the we added more and more reactive, power, right? So which means the actual the current is more magnitude is larger and more lagging, right? Which means if we add more here, which means more reactive power, it's coming out. But you can see from when I is one here and I one is gray or gray and blue line, the differences you can see, the voltage drop is related, right? Voltage drop is related here. So the result is just so you guys, remember this result. It's a reactive power. Q is here, and this angle is P. By the way, the result is it's flowing is from the big number of magnitude mechanism to downside. The flow is, you know what I mean? The result is. And then we also say this, you guys can see here, this part. We will say also equivalently, equivalently, not really saying, you know what I mean? We will say this is also voltage drop, we will say. But it's it's a short of a line. And then if depending on the angle, if the angle is, like a big, how it could be the same? This angle is I say theta 2. And then, yeah, if it's theta is, smaller, we will say this, actually, this is a voltage drop here, this blue line. But when also the theta is, smaller and shorter, line, we will say also this part equivalently, kind of, what I mean, voltage drop, we say. Why? I'll show you guys. Yeah, today is kind of a little bit messy and a little bit difficult, right? So, but don't worry about it. Let's see more. So first of all, I want to say is we actually have a R and JX in the line voltage drop, right? So actually, if it's I is coming, current is here. So voltage drop is actually I, and because R is same, in phase, right? Just resistive load, right? So it's the same. But I said that J is 90 degrees more precede, right? So that's why JX here, JX is here. So that's why if we add this part, the red dots line, this is actually voltage drop. But why we say this is just this line is the same? Because look at that here. Here's just theta, and here's just theta, right? First of all, this triangle, theta, right? And this is just theta. So first of all, we see this part, cosine theta, right? What is the cosine theta here? Actual voltage drops, you know what I mean? IJX, this part, right? IJX is a cosine part here, right? But here is this line too. It's a sine theta, right? IJX sine theta is this length. And here, what is that? Here is cosine theta. You can see. So IR's cosine theta is here. So that's why this is almost same. Wait. But I said depending on the angle. Angle is kind of this angle, smaller. It's almost same, really same. Like it's almost the equivalent of voltage drop. But more bigger and more long line, the angle is gonna be more, more long. The angle is more higher number, right? So which means it's a error there. Yeah, yeah, kind of yeah. It could be difficult today's lecture. But yeah, as I said, just remember the equation's meaning, and then what's the meaning? Vs is it's related Q, and here theta is P. Yeah, that's it. Today's lecture, guys. Thank you.